So back to the 6502 emulator. When we left it last time, got one failing test because we just didn't know how to solve it, which is to do with this, what we leave on when we return from an interrupt. How do we leave the processor state? Because we had conflicting information from two different websites saying different things. So they both can't be right, so that's a problem. And we have our test program that doesn't complete, but it does fail. Like it halts somewhere at some point in a break command, saying that there is, if I halt it in here, it's about 35B2. Yeah, it's got 35B2, where is it? Yeah, it looks like we're pushing the wrong address onto the stack after the break instruction. So we've got two problems there. So I think the first one to solve, let me just take this out again because this can't be left in because it will halt on success or failure. This test program. I think the first one to fix might be this one with the conflicting information, because I think the problem is this one here. What we've got is this website saying that when you come back from break, that bits 4 and 5, which is the break and the unused flag, are ignored, and this other website is saying that it's not affected. Now the thing I've worked out is this web page must be wrong. Well, I think this statement on this web page must be wrong, because what's actually happening here is you go into break, and then we're saying we always set bits 4 and 5 when we on the value that we push onto the stack. So we're pushing the processor states on, and we always set these two bits, which is the break and the unused flag. But we also always set the interrupt disable as well on the processor. Now what that means is if you're doing that, you can't issue another break while you're inside a break. It's not possible, because what this flag does, the interrupt disable, it says don't allow any interrupts. So the break forces an interrupt, so it can't happen again. So you can't break inside a break. So that's the first thing. So what that must mean is that when you come out of a break, you must have to unset the break flag, because you can't be in a break ever again at that point. That's my understanding of it anyway. So when they say they ignore bits 4 and 5, that doesn't mean they ignore them, it means they clear them, and that's different to ignoring them. So this website is, I think, wrong. Because if you didn't clear them, you'd never be able to get out of the break. It would just, or it would be left to the programmer to get to unset the break flags afterwards, which would be really weird, I think. I don't think that that's true, that they ignore bits 4 and 5. I think that this is true, is that they are basically not affected. But actually, in effect, what they're actually is, they're always cleared, because you can't be, sorry, the interrupts, which one is it, the break command? When you return from interrupt, sorry, this is RTI. Yeah, set from the stack. But break must have been 0 at that point, so you've got to clear it. But when you write it on the stack, you do set it, and for the reasons they're saying here is because the CPU needs these bits to identify whether it came from a break or from an interrupt request. So that's pretty complicated, but at the end of the day, it does make this simpler, I think, because this code that I was writing in here to do RTI, is that right? The RTI code here will just always clear the break, and it will clear the unused flag as well. So we just clear those afterwards. So they're not ignored, they're just cleared. And then when we pop from the stack in here, in fact, we can put that code in there, can't we? So yeah, so this can go in here. So clearing bits, yeah. I think that's more like it. And if that's the case, the way we're doing this stuff where we're just clearing them, I'm not sure if all of this is really necessary anymore, because now we can just pop the byte from the stack and then clear the two flags that we don't want. So that just becomes that. All that jumping through hoops was for something that I just think doesn't work. Really, I think that's really what it is. Yeah, I think that's right. So does that pass the test? So PLP ignores, but oh, so this is we've written another test now that's now wrong based on that code. So I think that's we want to get rid of that. Stack operations tests. Oh, it's this one. So yeah, in effect, I was saying that this one would leave these intact and it won't anymore. The processor states before should just be 0 in this case. Oh, actually no, because we couldn't ever go into it with those, so this is not right. It'll just be PLP clears bits 4 and 5 when pulling from the stack. So we're just making sure. I'm not sure if this is like a duplicate test now, but that's the correct test, I think. What are we doing here? Oh yeah, we're just setting up these bits, how the stack would have been with these bits on it. Okay. Right, I think that's right. That's all the test passing. So that's pretty good. I think this is wrong. Ignoring is not the same as clearing. Clearing is when you're doing something, ignoring is when you're not doing something. So can't be the same thing. Impossible. So I think I've cleared that up. The next thing is, does this still get to the same point, this test program that we've got? So it's so this is the test program we're running, this Klaus 2M5's functional tests here. We're trying to get through this whole thing that basically tests everything. So we've compiled that and we're trying to test it. So how far do we get? And the answer is, so it will always halt on success or failure, but the question is where? So did we get to the end yet? And the answer is we're pretty much in the same place. So those changes we made haven't done anything yet, but we are stuck at 3.5b1, which is the values on the stack are being pushed wrong. Now this is an interesting one because I've been looking this up, trying to figure out what the hell, why would these be wrong? And it turns out the answer is the break command actually does take 2 program counters. It's very weird. It's not listed on here. It kind of says it on here. Break command is intended for debugging. So you put it in the program and it basically sets an interrupt. The break command increments the program counter by 2 instead of 1. Right. So this is interesting that it will actually move the program counter on 2 for some reason. And that means that weirdly you have to put something after the break to stop the program screwing up, because it is only a 1-byte instruction, but it does increment the program counter by 2. I don't know. I don't think it actually increments the program counter by 2. I think it writes the program counter plus 1 onto the stack to skip over the next byte for some reason. So yeah, that's just super odd. And there was another website confirming that as well. Is it this one? Yeah, unlike IQ, the program counter pushed onto the stack does not point to the byte immediately after opcode, but instead the second byte after the opcode. So this is person saying this is very weird. So I think it's just something to do with the way breaks and IQs are handled in the hardware, and they're probably the same stuff. But essentially, the break command does not go back to the byte after. It goes back to the byte after that one. So I think that's what this test is actually telling us, that we didn't push the correct value onto the stack. It's the wrong value. So that's the thing we need to fix. So what would that be? Get rid of this information now. Yeah, let's get rid of that. This is the test here. So we've got a break command. We are testing that the value we push into the stack, we tested that it was the value after, which is this. So we're at FF00 and you would be FF01 to continue on after that break command. But actually it goes 1 past that. So it actually goes to 2. So that's just absolutely crazy, but that's the way it works. So yet another thing here. And other websites were saying actually the CPU does actually read the byte afterwards as well, but just doesn't do anything with it. So that's really odd. Yeah, so that's why we actually expect to skip over that byte, and really we would have a NOP after that. We don't need it here because we're not actually going to execute. We're not going to execute anything past the break in this case. So yeah, this gets complicated and more complicated. So it's not 01, it's 02. So that's going to make a lot of stuff fail, or at least one test fail. Oh, no it won't, because we've got our hanging program in there. Take that out for now. So there you go, so break pushes, yeah, break needs to push a different value onto the stack. So let's go and look at that. So it doesn't want to push the program counter onto the stack anymore. It wants to push the program counter plus 1 onto the stack. That's the deal. because we executed the break instruction, we moved on by one, and we want to move on another one after that. So this becomes PC plus one onto the stack. So there we go. Is that right? Yeah, we're pushing the program counter onto the stack plus one, setting the processor status onto the stack. We're reading the interrupt vector, and then we're moving to there, and we're setting the break to true. Okay. It's also saying break affects the interrupt status flag, which, yeah, that's true there as well, isn't it? Oh, but I actually added it on into there. Yeah, that's probably a bit weird that we did that, because I really shouldn't be doing that, I think. Yeah, I might take that code out as well. And we'll put it into the break. So PHP doesn't set the interrupt flag, and this one does. We don't need this anymore. I mean, really, we should. Yeah. I think that's okay. Let's just remove this. Oh, the program's gone. Let's just see if we still. Oh, we're not passing anymore. What did I do? Oh, that's the one we haven't fixed yet. RT error can return for an interrupt leaving the CPU in the state it started when it entered. Because we don't expect this to go. We don't expect it to go back to the byte after. We expect it to go to the byte after that. All right, that's that. Yeah, I think that's correct. Yeah. So that made another test fail, but the test is wrong in that case. So I think this is right now. So let's go back to our test program and see if we can get any further through that. And the answer is it crashed because it actually failed the test, and that means it must have thrown an exception. And yeah, I think it's thrown an exception and something's gone wrong in there. So that's not good. So that's got worse, possibly. I wonder how far we got before it failed. I think it might be. Isn't there a printf in here where it goes? I wonder if it did that. Yeah, I wonder if it's getting to here. It is. It's going. Yeah, instruction 150 not handled. So that made it worse, not better, which is pretty odd. I don't know what all this garbage is we've got in here. I don't know if this is any of this is right. But we must have done something different because we got past that part of the program. So what is instruction 150? Have we not implemented that? Maybe that's what we've actually done. Maybe that's what's wrong. I don't know, I've not checked. That's hex 96. Is that right? Yeah, hex 96. I wonder if we've missed an instruction out. Possibly have. Store X. Uh-oh. Have I not done that? Uh-oh. I thought we were done here. I was thinking, what could be the problem in this whole thing? I think it actually might be that I've not actually handled that instruction. So that would be, if I'd called it, it would have been STX Zero Page Y. No, it's a missing instruction. So there you go. So that's what's going on there. Okay. Cool, so this program's found us another problem. So now we can write a test for that. Blimey. That was really confused as to what was actually going on. I don't know why I didn't just think it's actually not an instruction that I thought the program had gone into some funny area and was executing code that it shouldn't. But actually it's not. It's actually just not we've just not put that in. You can see I've never clicked on it. So so let's go and find the test for that and add the test for zero page Y. This is one of the ones we did right at the start. Store X register, is it, what have I called it? Store register tests. Yeah, I've got STX Zero Page can store the X register memory, and then there's no STX Zero Page Y, is there? It's just not there. Yeah, I just haven't done it. I wonder if I implemented a... Oh, I don't know. Let's see if we can do this. STX Zero Page Y can store the X register into memory. STX Zero Page Y. Have we got test store zero page Y? Oh no, I haven't. Haven't even written it. Damn. Absolutely damn. So zero page X and zero page Y are actually identical, aren't they? Yeah. That's just really stupid. So it's just this, but with a Y on the end. Yeah, never did it. God damn. And this is exactly the same, except it's the Y register there. Yeah, I think that's it. That's the entire test. It's just the same thing with a Y register. And yeah, we just never did it. Just never did it. There it is. Yeah, look, it's missing. Damn. 96, was it? Yeah, I've taken that. I'm just checking I've taken that test out. Yeah, zero page Y can store the X register into memory. Never did it. Just never did it. It's really that, I think. Yeah. Wow. So that was a missing instruction. Okay, let's go with our program again. See if we can get a little bit further. Here we go. So confused there, that didn't make any sense. Oh, it's still crashing. I wonder if there's another missing instruction. Because that's one of the reasons it crashes, unless it's gone into... There is an assert for decimal mode as well. E5, what's that? Subtract with carry zero page. I wonder if I've not done that. I mean, because that is an instruction, so it's supposed to be in this list. I wonder if I've missed it out. Let's check that one. Oh. Did I not do any of the subtract with carry? Oh, did I just forget to do all that? Oh my word. What have I done? So this might just be a complete oversight that I completely forgot to do all the addressing modes for subtract with carry. I can't believe I did this. I thought I wrote these. Let's just see. No, I really just didn't do them at all. So there's a load of stuff missing here for subtract with carry. Yeah, that's terrible. Why did I do that? Right, so I'll continue with this in the next video, and we'll put the rest of the subtract with carry addressing modes in, and then see if we can get any further with the addressing modes. But at least I feel like we're getting a bit further now. I didn't realize I had so many missing instructions. So that's really bad that I just forgot all this. Oh, that's terrible. So it shows how easy this kind of thing is to do, really. But yeah, more tests for the next one, and then we continue on with the program. Right, I'll catch you for that one.